Good day, everyone. So my name is Ray Miguel B. De Los Reyes, and for today, we'll discuss our topic that relates in Calculus 2. so, and so the topics that we will discuss about you is about the alternating series and the absolutely and conditionally convergence. So let us start the alternating series. So ano ba yung sinasabi natin dito na alternating series? Ang sinasabi dito, a series whose terms alternate between positive and negative values is an alternating series. An alternating series can be written in the form the summation of negative 1 raised to n times b sub n from n equals 1 up to infinity equals negative b sub 1 plus b sub 2 minus b sub 3 plus b sub 4 and so on. Or n the summation of negative 1 raised to n plus 1 times b sub n from n equals 1 to up to infinity is equals to b sub 1 minus b sub 2 plus b sub 3 minus b sub 4 plus and so on. As you can see, pag sinabi nating alternating series, kaya siya tinawag noon dahil kung mapapansin natin, yung mga signs natin is alternating. Okay? Naka-alternate siya. Mapapansin nyo, ayan. So, negative, positive, negative, positive, negative, or maybe negative, positive, negative, positive, negative, and positive, and so on and so forth. Then, series is lahat yung mga terms na yan, so additionally. So, nag-a-add lang tayo dyan. No? Kaya siya tinawag na alternating series. So, sa alternating series test, an alternating series of the form, ayan, so summation of negative 1 raised to n times b sub n from n equals 1 up to infinity, or the summation of negative 1 raised to n plus 1 times the b sub n from n equals 1 up to infinity are converges for b sub n is greater than 0 if the b sub n plus 1 is less than b sub n, for n is the natural numbers and the limit of b sub n such n approach to infinity equals 0. So, sinasabi dito na kapag ang alternating series by using the alternating series tests is convergence kapag yung b sub n plus 1 natin is less than to b sub n. So, ibig sabihin, mas mababa dapat yung value yung nasa b sub n plus 1 kaysa sa b sub n. Dapat yung b sub n natin, kapag kinuhanan natin yung limit niyan, such n approaches infinity, makuha dapat natin si 0. So, meron tayong mga dalawang conditions na magpapatunay na yung isang alternating series is convergence. And then kapag ang isa sa mga dito ay hindi nag-satisfy, therefore that is the divergence. So here's the examples. Determine whether the series is convergence or diverges. Ito yung number 1, the summation of negative 1 raised to n plus 1 over n squared for n equals 1 up to infinity. And then, the summation of negative 1 raised to n plus 1 times n over n plus 1 for n equals 1 up to infinity. So, unahin muna natin yung first equation. No? Yung first series, rather. So, paano malaman natin, since itong series na to is an alternating series. So kapag pinahaba natin yan, magiging itsura niyan is alternating series. So let b sub n equals n 1 over n squared, kasi pag binaba natin dito, ang makukuha natin is 1 over n squared. So yung b sub n natin is 1 over n squared. So for the first condition, ayan, 1 over substitute lang natin, you have 1 over n plus 1 squared is less than 1 over n squared. And then, simplify natin, we have 1 over n squared plus 2n plus 1 summation is less than 1 squared, 1 over n squared. Ayan. As you can see, for n is natural numbers, we can say that b sub n plus 1 is less than b sub n. Dahil kung mapapansin natin, kapag sinubstitute natin yung mga numbers na yan, then kapag in-evaluate natin, mas mababa yung yun nandito, yung nasa term na n plus 1 term kaysa doon sa n term. So therefore, the first condition is true or satisfy. So dahil satisfy yan, tingnan natin yung second condition. Ayan. Yung limit, kunin natin yung limit such n approach to infinity ng b sub n. So as you can see, yung evaluate lang natin 1 over infinite. Ayan, over infinite. So based on the limit properties of limits, ayan, so based dun sa limit, 1 over infinity is equals to 0. So 1 over infinite, ay, that is equals to 0. Ayan. So therefore, the limit of the b sub n such n approach to infinity equals 0. So dahil nag-satisfy yung dalawang conditions natin, masasabi natin by the alternating series test, the series of summation of -1 raised to n plus 1 over n squared from n equals 1 up to infinity is convergence. And for the second series, second alternating series, this series is an alternating series. Kasi, ayan, mayroon tayong -1 raised to n plus 1. Then, kunin natin yung b sub n natin, which is yung n over n plus 1. Dahil ito yung magiging basis natin. Then, next one is yung first condition. Test natin kung first condition. Ayan. So, n plus 1 over n plus 1 plus 1 summation is less than n over n plus 1. Ayan. Then, ano yun natin? No? N plus 1 over n plus 2 is less than n is less over n plus 1. As you can see, kapag sinubstitute natin yan for n natural numbers, mas mataas yung nasa n plus 1 term. Therefore, for n is natural number, we can say that b sub n plus 1 is greater than b sub n. Therefore, the first conditions are not satisfied. So as you can see, so summation of -1 raised to n plus 1 times n over n plus 1 for n equals 1 up to infinity is diverges. Next, determine if the series of -1 raised to n plus 1 over 7 plus 2n from n equals 1 up to infinity. So you can see, instead na n plus 1, mapapansin niyo n of minus 1. Pero, huwag kayong mabother or huwag kayong magbahala kasi alternating series pa rin yan. Yan. So, dahil alternating series pa rin yan, we can say that the b sub n equals 1 over 7 plus 2n. For the first condition, ganun lang din, substitute lang natin, we have 1 over 7 plus 2 times the quantity of n plus 1 is less than 1 over 7 plus 2n. And then, kunin natin, we have 1 over 9 plus 2n is less than 1 over 7 plus 2n. So as you can see, yung denominator natin mas mataas dun sa denominator ng isa. So base dun sa pinaka-property ng fraction, kapag mas mataas yung denominator, mababa yung magiging value niyan. So dahil mas mababa yung value ng 1 over 9 plus 2n kaysa dun sa 1 over 7 plus 2n, we can say that for n is an element of natural numbers, we can say that the b sub n plus 1 is less than b sub n. Therefore, the first condition is true or satisfied. For the second condition naman, kunin lang natin yung limit such n approach to infinity yung b sub n. And then, substitute lang natin, we have 1 over 7 plus 2n times the infinite. So, dahil infinite yan, we consider na 1 over infinite pa din yan. And then, kapag 1 over infinity, equivalent yan sa 0. Ayan. So, the limit of b sub n such n approach to infinity equals 0. So, dahil satisfy yung dalawa nating conditions, we can say by AST or alternating series test, the summation of -1 raised to n plus 1 over n squared from n equals 1 up to infinity is convergence. Ayan. Next naman is determine if the series summation of -1 raised to n times n squared over n squared plus 5 from n equals 1 up to infinity is convergence or divergence. Ayan. So solution is an alternating series pa din yan. Kasi yung regular na n equals 1 raised to n. So dahil alternating series, we can say i-consider natin yung b sub n is n squared over n squared plus 5. Then kunin natin yung first conditions. So n plus 1 squared over n plus 1 squared plus 5 is less than n squared over n squared plus 5. And then pag simplify natin, we have n squared plus 2n plus 1 times n squared plus 2n plus 6. And then is less than n squared plus n squared plus 5. So pag sinubstitute lang natin, mas mataas ito kumpara dito. So we can say for n is natural number, we can say that the b sub n plus 1 is greater than b sub n. Therefore, the first condition are not satisfied. So hindi siya satisfy. Makukonsider natin na the summation of negative 1 raised to n plus 1 times n over n plus 1 from n equals 1 up to infinity is diverges. Next is to determine if the series summation of cosine pi n over square root of n plus 1 from n equals 0 up to infinity is converges or diverges. We know that the cosine of cosine of pi n equals negative 1 raised to n. So then substitute lang natin yun. Palitan lang natin yung n equals yung negative 1 raised to n instead of cosine pi n. Kaya magiging summation of negative 1 raised to n over square root of n plus 1 from n equals 0 up to infinity. So dahil alternating series siya, let p sub n equals 1 over square root of n plus 1. For the first condition, ayan, kunin natin yung first condition. So substitute lang natin yung n sub n plus 1 sa kabila, then copy yung ano natin. So 1 over square root of n plus 1 plus 1 is less than 1 over square root of n plus 1. Then n over square root of n plus 2 is less than 1 over n plus 1. Square root of n plus 1 rather. So as n increases, 1 over n plus 1 decreases. So sabi dito, kapag yung n nag-i-increase, nagdi-decrease naman yung kabuuan. Ayan, yung kabuuan nito. Therefore, the first condition is satisfied. Ayan. For the second condition, kunin lang natin yung limit such n approach to infinity yung b sub n natin, which is yung 1 over n plus, square root of n plus 1. So dahil 1 over square root of infinite plus 1, we can, makukonsider natin as 1 over infinite yan. And then 1 over infinite is 0. Then, so the limit of b sub n such n approach to infinity equals 0. So by the alternating series test, the limit of cosine pi n over square root of n plus 1 from n equals 0 up to infinity is converges. Ayan. So tapos na tayo dun sa alternating series test. Dako naman tayo sa absolutely and conditionally convergent. So ano ba yung sinasabi niya rito? A series of summation of a sub n is called absolutely convergent if the summation of absolute a sub n is convergent, if the summation of a sub n is convergent, and the summation of absolute a sub n is divergent, we call the series conditionally convergent. Sinasabi lang dito na kapag ang summation of a sub n is absolutely convergent if yung summation of a sub n natin at saka yung summation of absolute of a sub n natin is parehong convergent. Pero kapag ang a sub n natin, yung summation of a sub n natin is convergent, pero yung summation of absolute of a sub n is divergent, ang tawag sa kanya is conditionally convergent. Fact. So ito yung fact, if the summation of a sub n is absolutely convergent, then it is also convergent. Ayan. So syempre, since absolutely convergent yan, pareho lang naman sila convergent na rin ang tawag sa kanya. Kasi pareho lang naman sila convergent. So the P-series test, ano naman ang sinasabi niya rito? The P-series test states that the series summation of 1 over n raised to p converges if p is greater than 1 and the diverges if p is less than or equal to 1. Therefore, if the series of summation of absolute of a sub n can be written in the form summation of 1 over n raised to p, then the convergence or divergence of the series can be determined using the p-series test. If the value of p is greater than 1, the series convergence absolutely. If the value of p is less than or equal to 1, the series divergence. Ayan. So, simple lang yung paliwanag niya rito. Sa paggamit ng p-series tests, using the summation of 1 over n raised to p, titingnan lang natin kung siya ba ay greater than or less than or equal to 1. Kapag na greater than 1 yan, or mas mataas siya sa 1, no, convergence siya. Pero kapag less than or equal sa 1, yung P natin, yung value ng P natin, that is a divergence. Ayun. Next is the geometric series tests. The geometric series test is the method to determine whether an infinite series of the form summation of a times r raised to n minus 1, where a is a non-zero constant and r is the real number, is convergent or divergent. The geometric series test states that if absolute of r is less than 1, then the series of summation of a r and raised to n minus 1 converges to a over 1 minus r. If the absolute of r is greater than or equal to 1, then the series of summation of ar raised to n minus 1 diverges. So sa geometric series naman, if ito lang naman yung kanyang palatandaan o yung mga conditions. If if the absolute of r is less than 1, yung summation na ito is convergence to a over 1 minus r. The rest, kapag greater than or equal sa 1, divergence siya. Yung P-series and geometric series test, yan yung gagamitin natin kapag magsusolve tayo ng, kapag ma-identify natin yung absolutely or if the series is absolutely or conditionally convergent. Pero, so dagdag ko lang din, if yung dalawang if yung natin, yung summation of a sub n at saka yung summation of absolutely a sub n is parehong divergence, syempre, ang tawag sa kanya divergence yan. So, yun ay tinatawag na common sense, kumbaga yan, natural or obviously divergence siya. No? Ayan. So here's the example here. Determine if the summation of negative 1 raised to n plus 1 over cube root of n from n equals 1 up to infinity is absolute, convergent, conditionally convergent, or divergent. Sa first condition, ayan, let a sub n equals negative 1, the quantity of negative 1 raised to n plus 1 over cube root of n. So gamitan natin yung tinatawag, ayan, ganito yung gawin natin. The summation of absolute a sub n from n equals 1 up to infinity. Ayan. So, substitute lang natin, we have summation of absolute negative 1 raised to n plus 1 over cube root of n from n equals 1 up to infinity. And then, kapag kinuha na natin yung absolute niyan, magiging negative 1 na siya. Ayan. Magiging positive 1 na siya, no? Kaya, magiging 1 over cube root of n. At saka pwede nating sabihin na pwede rin natin i-convert as 1 over n raised to 1/3. Ginawa lang natin siyang exponential form from radical form. Then as you can see, meron tayong exponent na 1 over 3 sa n. So gagamit tayo ng P-series dyan. We know that the P-series is 1/3 at yung 1/3 is less than or equal sa 1. Then that it is a divergent. Ayan. So, dahil divergent siya, kunin natin yung second condition. Using the alternating series tests, let a sub n equals 1 over 3 cube root of n. Ayan. So, same lang din dun sa nauna, from a over a sub n plus 1 is less than a sub n. Substitute lang natin, we have 1 over cube root of n plus 1 is less than 1 over cube root of n. So, dahil mas mataas yung denominator, mababa yung magiging value kapag fraction. So dahil mas mababa ito, we can say that the 1 over cube root of n plus 1 is less than 1 over cube root of n is true. So satisfy siya. And then kunin natin yung limit. So limit of 1 over cube root of n is less approach to infinity. So pwede nating sabihin na 1 over summation infinity, which is equivalent to 0. Then the this series is convergent. So dahil divergent yung isa at convergent naman yung isa, therefore, mapasasabi natin in conclusion, the series of summation of negative 1 plus 1 over cube root of n from n equals 1 up to infinity is conditionally convergent. Ayan. Next is determine if the summation of negative 1 raised to n plus 1 over 3 raised to n raised to 4, 3n raised to 4 minus n is absolute, conditional, convergent, or divergent. So, ganun lang din yung gawin natin katulad ng nauna. Kunin, sa first condition, kunin lang natin yung absolute nito. So, let A sub n equals negative 1 raised to n plus 1 over 3n raised to 4 minus n. Then, kunin natin absolute, magiging negative 1 n raised to n plus 1 over 3n raised to 4 minus n. So, pag sinimplify natin, magiging summation of, excuse me, magiging 1 over 3n raised to 4 minus n. We know that the p equals 4, then it is a convergent kasi mas mataas siya sa 1. Then, kunin lang natin ito, no? Consider natin yung, ano natin, ano? Ginamit lang natin dito yung p-series. Next, for the second condition naman, by using the alternating series test, let a sub n equals 1 over 3n raised to 4 minus n. Then, gawin lang natin ginawa natin kanina, substitute, ayan, then compare natin. Ayan, so mas mataas ito, mas mataas yung denominator, then mababa naman yung value nito. Then, masasabi natin yung 1 over 3 times n plus 1 raised to 4 minus n plus 1 is less than 1 over 3 raised to 3n raised to 4 minus n is true. Then kunin natin yung kanyang limit. So kapag sinimplify natin agad, magiging infinite yung denominator natin and then 1 over infinite which is 0. So that is a convergent. Dahil convergent silang pareho, in conclusion, the series of negative 1 raised to n plus 1 over 3n raised to 4 minus n for n equals 1 up to infinity is absolutely convergent. Next, determine if the summation of 1/2 raised to n from n equals 1 up to infinity is absolutely convergent, conditionally convergent, or divergent. The first condition, let a sub n equals 1/2 raised to n. Excuse me again. Ayan. And kunin natin yung absolute. So, 1/2 raised to n, ang absolute niyan magiging 1 over 2 raised to n. We know that the absolute r, the absolute of r is less than 1, then it is a convergent. Kasi kahit na ano na gawin natin dyan, kapag sinubstitute lang natin yan, mas mababa yung magiging value. Tandaan natin, kapag lumalaki yung value ng denominator, lumiliit yung value ng kabuuan ng fraction. So, kasi ito yung nagsisilbi nating r. Yan, ito yung magiging r natin. So, we know that the absolute of r is less than 1, convergent siya. Second condition naman, by using the alternating series test, so, ganun din, ilalet natin sa a sub n yung 1/2 raised to n. Then, gawin lang natin yung ginawa natin kanina, substitute lang yon. 1/2 raised to n plus 1 is less than 1/2 raised to n. So, sabi dito, that is a true. Kasi mas mataas, mas mababa yung magiging value niya. And then, kunin natin yung limit. The limit of n, summation of infinite, limit of 1/2 raised to n such n approach to infinity equals 0. Ayan. Therefore, it is a convergent pa din. So dahil convergent sila pareho, in conclusion, the series of the summation of 1/2 raised to n for n equals 1 up to infinity is absolutely convergent. Ayan, so next is determine naman if the summation of negative 1 raised to n times 1/3 raised to n for n equals 1 up to infinity is absolute, conditional convergent, or divergent. First conditions, ayan, ilet lang natin yung yung ito, yung a sub n natin sa a sub n yung negative 1 raised to n times 1/3 raised to n. Then kunin lang natin absolute. Ayan. Then magiging sagot is 1/3 raised to n. And then since mas mataas yung mas mababa sa 1 yung absolute of r natin, which is ito, then it is a convergent pa din. Second condition, ayan, by using the alternating series test, a sub n equals 1/3 raised to n. Ayan, substitute lang natin. And then, then compared natin, so mas mataas, mas bababa dito compared dito, that is a true or satisfied. Then after that, kunin lang natin yung limit. Then the limit of 1/3 raised to n, such an approach to limit equals 0. Ayan. Then this is a convergent yan. Convergent kasi 0 siya. Then parehas naman silang convergent. This series is absolutely convergent. And so that's all for our session, for our topic in Calculus 2. Thank you for listening and have a great day, everyone.